Hello, and a very, very warm welcome to all. I am Geeta, and it is my immense pleasure to host the very interactive technical workshop Sungrow Energy Connect Nepal 2026. Nepal's renewable energy sector is evolving rapidly with solar, battery storage, and hydropower, creating new opportunities for more flexible and reliable energy systems. In this technical workshop powered by Sungrow, a global leader in renewable energy technology, will help us explore how advanced inverter technology, batteries, energy storage systems, and intelligent energy management can enhance solar and hybrid projects while complementing hydropower, strengthening grid stability, and enabling more efficient renewable energy integration. So before we start the webinar, a quick update for all our attendees. Since this is an interactive webinar and we would love to hear from you. So if you have any questions during the presentations, kindly type them into the Q&A box at any time. Sungrow technical experts will answer as many questions as possible during the Q&A session towards the end of the webinar. So keep those questions coming in. And now it is time for a quick poll just to understand our attendees of today and requesting everybody to kindly participate in this poll. Kindly describe your organizations and participate in the poll. Just a few more moments. Requesting everybody to kindly participate. Thank you, everybody, for your participation. And now, without any further delay, let us begin today's program. Starting the webinar with a very warm welcome address by Mr. Himanshu Anand, Manager Sungrow, who will be sharing overview of Sungrow's global journey and commitment to Nepal's energy market. Over to you, sir.
Thank you, Ms. Geeta. Namaste and good afternoon, everyone. It's my great pleasure to welcome all of you to Sungrow Nepal Connect webinar. Today, we will be focusing upon renewable energy solutions, specifically for the Nepal market. First of all, I would like to sincerely thank all of our customers, partners, consultants, EPCs, developers, and industry professionals from Nepal market who have come to join us today. Before we move into the technical sessions, I would like to take a few minutes to introduce Sungrow to you. For our global journey, our approach towards innovation, and most importantly, our commitment towards Nepal's renewable energy future. My friends, Sungrow started its journey in the year 1997 when Professor Kao founded the company with the clear focus on renewable energy and power electronics. At that time, when solar energy was still in a very nascent and emerging stage, Sungrow made a long-term commitment to developing technologies that could convert renewable energy into reliable and usable electricity. Over the past almost 3 decades, that vision has grown into a dedicated global renewable energy company now. Today, with our automated manufacturing facilities spread across China, India, Thailand, and Poland, Sungrow has deployed more than 870 gigawatts of power electronic converters globally as of June 2025. This includes 75 gigawatts of shipment from India unit alone. Today, Sungrow solutions are deployed in more than 180 countries globally, supporting the utility scale solar plants, commercial and industrial facilities, residential systems, microgrids, and some of the world's largest BESS projects. The company has developed a strong global service network with more than 520 service outlets globally, helping our customers not only with products but also with technical support. At the heart of our growth has been technology and innovation. Of our 17,000 plus staff, around 40% of Sungrow personals are dedicated towards R&D, reflecting the company's belief that renewable energy will continue to evolve rapidly. Sungrow's portfolio today extends beyond conventional solar inverters into energy storage, floating PV, automated PV cleaning robots, EV charging, wind, hydrogen, and integrated renewable energy solutions. Sungrow's mission is very simple: clean energy for all. For us, this means building more than products. It means building a bridge between renewable energy resources and reliable electricity, between global technology and the local requirements, between manufacturers, developers, distributors, and end customers. Specifically speaking, for the Nepal renewable energy segment, Nepal is a very important and promising market for us. The country has an exceptional renewable energy resource, particularly hydropower, while solar energy also has significant potential across residential, CNI, and utility applications. Hydropower generation varies significantly between monsoon and dry seasons. Solar generation available primarily only during daytime, while electricity demands often peaks in the evening. Distribution networks in many areas are becoming increasingly stressed as more distributed renewable energy is connected. Advanced power electronics and energy storage are becoming game changers for the renewable energy transition now. Modern solar inverters are not just DC to AC conversion devices. They have become intelligent grid support systems that help manage voltage, reactive power, frequency, power quality, and grid stability, overall enabling higher renewable energy integration. Similarly, battery energy storage systems are now strategic energy infrastructures, not just simply backup batteries. They can store renewable energy when it is available and deliver it when it's needed, while supporting peak shaving, energy shifting, providing stability to the grid, giving backup power, and, reducing dependence on diesel gensets. Energy storage can complement the country's hydropower and solar resources, improving the grid flexibility, supporting the industry, and maximize the use of Nepal's own clean energy resources. Sungrow established strong distribution and service partnership with Comtronics and Urja Global Private Limited in Nepal to strengthen its presence in Nepal renewable energy market. The partner the partnership initially focuses upon CNI and residential on-grid solutions. This is an important step because we believe that successful renewable energy adoption requires much more than just good technology. It requires strong local partners, trained technical team, reliable after-sales service, proper system design, knowledge sharing, and continuous engagement with the market stakeholders. So as we begin today's technical webinar, I would like to leave you with three simple messages. First, Sungrow brings nearly 3 decades of experience in renewable power conversion technology. Second, our commitment is not only global. We are focusing on building strong local partnerships and technical capabilities in Nepal itself. And third, we believe the clean energy transition is a journey that we must build together. To our clients, partners, and entire Nepal energy community, we look forward to working together to accelerate the adoption of clean, reliable, and intelligent energy solutions. Thank you once again for joining us today. And with that, I would like to welcome you all to the technical session and wish everyone a very productive and insightful webinar. Thank you, everyone.
Thank you so much, Mr. Himanshu. And now, ladies and gentlemen, before we begin the technical session, let's take a moment to know more about Sungrow and the journey behind its innovations in renewable energy. Here's a short video showcasing Sungrow's global presence, technological expertise, and commitment to building a sustainable energy future. Team, could we have the video, please?
We continuously ask ourselves, what does it truly mean to coexist with nature? What do we know about nature? It's about chasing the trail of light without leaving a single trace behind. It's about harnessing energy and unleashing creativity. It's about capturing the invisible and transforming it into something tangible. It's not about what we take from nature, but rather what we gain by giving back to it. It's about drawing power from the earth and sky, turning landscapes into canvases of innovation. It's about illuminating the night sky and raising the eternal stars. It's about creating homes that are both enduring and full of light, where life is filled with green power and imagination. What does it truly mean to coexist with nature? During the energy transformation, where nature converges with technology, an inexhaustible source of power emerges. From nature, we draw inspiration and creativity. With each moment, we take a step forward, building a bridge of new energy, bridge to a sustainable future.
Thank you so much. And now, ladies and gentlemen, just a quick time for a second poll. Kindly participate. Kindly share the renewable project capacity that you're currently developing or evaluating. Requesting everybody to kindly participate in the poll. We're ending the poll now. Thank you so much, everyone, for your participation. And now, ladies and gentlemen, moving to our first technical session on utility PV solutions enhancing solar project performance with advanced inverter and energy storage solutions. May I please welcome the Sungrow expert, Mr. Thomas Zhang, the PV solar expert of Asia Pacific, and Mr. Monu Tevatia, product application engineer, to kindly take the session ahead. Could I
Hello
have Mr.
everyone.
Thomas?
So let me share my screen now. Good afternoon everyone. Namaste. My name is Thomas. I'm solution engineer of Sungrow South Asia team. Today I will introduce Sungrow's utility scale PV inverter solutions. And we will cover both string and central products. This is Sungrow's utility inverter portfolio for today. The SG510HX is our next generation high power string inverter and will be the main focus of the first section. And the next one is SG350HX. The second generation is a mature and proven string solution. So I will introduce it briefly later without repeating the same functions. And finally, we will look at the 1+X modular inverter, designed for large and ultra-large utility plants. The right choice depends on the plant size, terrain, grid conditions, and commercial priorities. So let's start with SG510HX. Its maximum output power reaches 511.5 kilowatts with 465 kilowatts at 40 degrees Celsius and 420 kilowatts at 50 degrees Celsius. It also introduces a 1000-volt AC architecture. Higher inverter power and higher AC voltage allow fewer inverter units, lower current, reduced cable requirements, and higher power density. So SG510HX is not simply a large inverter. It enables a different system architecture for the next generation of utility PV. This model will be available from March 2027. So compared with our previous model, the SG350HX, the second generation, our 510 model increased maximum power from around 350 to 510 kilowatts, while AC voltage rises from 800 to 1000 volts. Maximum current per MPPT also increased from 75 to 105 amps. At the same time, the weight remains below 130 kilograms. So overall, we achieve about 45% higher power, 25% higher AC voltage, and 28% higher power density. For EPCs, that means fewer units and installation points. And for owners, I think it creates additional BOS savings. This slide shows that the system level benefit based on a standardized 100 megawatt plant model. A 465 kilowatt solution can save around 0.058 US cents per watt compared with a conventional 320 kilowatt solution. Most of the saving comes from cable optimization and installation. The important point is that inverter value should not be judged only by efficiency or purchase price. It also affects cable quantity, block design, and overall BOS cost. Large PV projects often face a simple problem. The plant is ready for commissioning, but permanent auxiliary power is not yet available. And traditionally, I think EPCs rely on diesel generators. But with Sungrow's off-grid commissioning, the inverter can operate in voltage source mode and use PV power to support construction tools, testing equipment, and communication systems. This reduces diesel use and the logistics as well, and help achieve earlier commercial operation. For a 1 gigawatt project, the example shown here can support up to 30 days earlier commercial operation date. Traditional plant control may distribute reactive power evenly across all inverters, but some inverters may already be producing high active power while others still have spare capacity. If reactive power is shared equally, the heavily loaded inverter may need to reduce active power. Sungrow dynamically identifies busy or sleeping inverters, assigning more reactive power to those with available capacity. The grid requirement is still met, but active power generation is maximized. Now let's look at our grid forming technology. Traditional grid following inverters detect and follow the existing grid. This works well in a strong grid, but weak grids can create voltage, frequency, and oscillation problems. Grid forming works differently. The inverter behaves more like a voltage source and actively supports the grid. Our PV VSG technology can provide voltage support, damping control, inertia response, primary frequency response, and enhanced fault write-through. In simple terms, grid following adapts to the grid, while grid forming actively supports the grid. One important grid forming function is the inertia support. Unlike synchronous generators, PV inverters have no physical rotating mass. Sungrow therefore emulates synchronous generator behavior through control algorithms. The inverter can respond to frequency changes within 5 milliseconds, providing very fast virtual inertia. Because this response happens locally at inverter level, it is much faster than waiting for a plant controller to measure, calculate, and send commands. Grid faults can also cause transient overvoltage. If the inverter responds too slowly, protection may operate and disconnect the unit. With grid forming control, the inverter rapidly adjust the reactive power and actively support the voltage. This helps suppress transient overvoltage and keep the inverter connected through the fault. For weak grids and demanding grid codes, this significantly improves fault write-through capability. Weak grids can also suffer from wideband oscillation caused by interaction between inverter impedance and grid impedance. Traditional plant level control is relatively slow, but our solution provides active damping directly at inverter level, helping suppress oscillation over a wide frequency range. The objective is to maintain stable operation even in very weak or highly renewable grids. Now we move to safety. Sungrow's smart shutdown solution, the third generation, combines a mechanical switch and an electronic switch. If the primary path cannot interrupt an extreme fault correctly, the electronic path can provide additional protection and help reduce arc flash risk. The system also includes intelligent lockout, preventing accidental reclosing before the fault is cleared. So the focus is not only fault disconnection, but the safe and reliable isolation. Utility PV plants face lightning risk during construction, standby, and normal operation. We validate lightning protection under 15 extreme operation scenarios. Simulation is used to identify weak points in the lightning path, and PCB design is optimized to protect sensitive circuits. The goal is full lifecycle protection rather than protection under only one operating condition. Our SG510HX also includes real-time temperature sensing at DC and AC terminals. This helps identify abnormal heating caused by loose connections or installation issues before they develop into larger faults. MPPT level installation monitoring also improves fault localization precision. For O&M teams, faster detection and faster detection mean lower safety risk and shorter repair time. The SG510HX is designed for harsh environments. It provides IP66 protection and C5M corrosion resistance, together with active dehumidification. The design has also been validated through soft spray and dam heat testing. This improves long-term reliability in coastal, humid, and dusty environments. So dust, sand, and insects can block cooling air ducts and increase maintenance work. Our inverter monitors air duct condition in real time. If blockage is detected, the fan can automatically reverse to remove debris. This turns routine manual inspection into a more intelligent, condition-based maintenance process. Another thing is our smart IV2 supports automated module and string level fault diagnosis. It can identify 22 fault types, quantify energy loss, and locate problem areas. The slide shows more than 36 gigawatts of global deployment and the diagnosis accuracy of more than 97%. The customer benefit is simple: faster fault identification, less manual inspection, and quicker recovery of lost generation. Before introducing our SG350HX second generation, this slide shows our experience in high power string inverter. Contracts for the SG350HX series has already exceeded 50 gigawatts across hot, cold, desert, mountainous, and corrosive environments. SG510HX is the next generation, but it is built on this large field experience. So our SG350HX the second generation is our mature and available now high power string inverter. It provides up to 352 kilowatts, 75 amp per MPPT, 6 MPPTs, and a voltage range of 500 to 1500 volts. Its key strength is maturity and flexibility. For projects requiring a proven 1500 volt DC and 800 volt AC platform today, I think SG350HX, the second generation, is a strong choice. For future higher power, 1000 volt AC design, then the SG510 series is more forward-looking, but it will be available from March next year. Now let's move to the 1 plus X modular inverter. Each unit is 1.1 megawatts, and multiple units can be connected in parallel to create subarrays from 1.1 to 8.8 megawatts. The concept combines modularity and redundancy with the system economics of large, centralized solutions. Its three main values are lower LCOE, comprehensive safety, and reliable grid support. For 1 plus X, lower LCOE means several areas. These include flexible plant design, lower fault losses, faster maintenance, smart IV diagnosis, multiple MPPTs, and off-grid commissioning. So the benefit is not just the inverter efficiency. It is a combination of lower capex, higher availability, and better lifetime energy yield. So each 1.1 megawatt unit can be combined to form different subarray sizes. This gives EPCs or owners greater flexibility on hills, irregular land, or water surfaces. Instead of forcing the site into one fixed block size, the electrical design can follow the terrain. This helps optimize land use and system cost. Modularity also improves plant availability. If one 1.1 megawatt unit fails, the other unit continue operating. A faulty unit can be replaced quickly using a standby machine. The example here shows a generation loss reduction of up to 95% compared with traditional long repair periods. This directly protects project revenue. Important components such as fans and IGBT modules use modular plug-and-play design. Replacement time can be reduced from around 6 hours to within 2 hours. This improves maintenance efficiency by about 70% and reduce dependence on highly specialized technicians. The 1 plus X solution also supports smart IV diagnosis through Sungrow smart combiner boxes. It can identify 16 faulty types, achieve more than 95% recognition accuracy, and complete diagnosis and reporting around 15 minutes only. This greatly reduces the need for large-scale manual inspection. And this technology has been already applied in projects over 20 gigawatts. 1 plus X also supports off-grid commissioning. The inverter can establish a temporary grid using PV power, reducing dependence on diesel generators. The slide shows potential for 7 to 30 days earlier grid connection. For larger projects, every additional day of generation can represent a meaningful revenue. Multiple MPPTs improve adaptability to the complex terrain. Different module groups can operate under different orientations or shading conditions without strongly affecting each other. The slide shows up to 8 MPPTs in an 8.8 megawatt subarray. This improves generation on uneven or non-uniform sites. The second major pillar of 1 plus X is safety. The following slides cover DC arc detection, internal fault protection, wind and sand resistance, thermal design, and environmental protection. The objective is to protect both personnel and equipment throughout the plant lifetime. Our 1 plus X system continuously monitors the DC side for parallel arc faults. When a fault detected, it can respond and disconnect within approximately only 40 milliseconds. The inverter can also coordinate with Sungrow smart combined boxes to isolate the risk across the subarray. This can provide fast and intelligent fault protection. The cabinet includes a dedicated internal fault pressure relief design. An explosion-proof lock helps to prevent the door from being thrown open, while a pressure relief door provides a controlled release path. The design complies with international standards and has passed these Intertech ARC testing. For desert conditions like maybe Middle East, 1+X uses a smooth air duct design to reduce sand accumulation. The air inlet also helps resist direct wind and sand impact. The mesh can be removed for cleaning. These features reduce maintenance work while maintaining cooling performance. The inverter separates the power cavity from one electronic cavity. The power cavity uses direct ventilation, while the electronic cavity uses an independent heat exchanger. This allows efficient cooling while protecting sensitive electronics from dust and moisture. Uh, our inverter, uh, in our inverter, the electronic cavity provides IP65 protection and C5 anti-corrosion capability. The enclosure is sealed, and the cabinet uses corrosion-resistant coating and materials. This makes the solution suitable for deserts, plateaus, coastal regions, and high humidity environments. The third major pillar is grid support. The OnePlus-X solution is designed to operate in weak grids, ride through voltage disturbances, and respond quickly to grid commands. The next three slides demonstrate these capabilities. The OnePlus-X solution has demonstrated stable operation at SCR of 1.018, which represents an extremely weak grid. Technologies such as dynamic impedance, shaping, and transient overvoltage suppression help maintain stable operation. This is valuable for remote projects connected to weak transmission networks. The OnePlus-X solution can remain stable during continuous high or low voltage ride-through events. Fast waveform tracking and dynamic virtual impedance help avoid oscillation and disconnection. The objective is clear. When the grid is under stress, the inverter should remain connected and support recovery. The OnePlus-X inverter provides active and reactive power response within only 20 milliseconds. It can also provide up to 60% reactive power and operate in SVG mode when required. This fast response supports grid regulation and helps meet increasingly demanding grid code requirements. Global installed capacity of OnePlus-X modular inverters has exceeded 150 gigawatts. Projects shown here include China, Americas, Europe, Middle Asia, and Middle East. This demonstrates that OnePlus-X is not only a technical concept, but also a globally deployed utility-scale platform. So how should we choose between string and modular solutions? String inverters are particularly strong in terrain adaptability, and redundancy. Modular or centralized architectures are often more attractive for very very large plants where capex and the large block optimizations are important. There is no single answer for every project. The final selection should consider terrain, plant size, grid strength, availability targets, and the local cost structure. I think to summarize, SG510HX is our next generation high power string inverter, focused on high power density and stronger BOS optimization. SG350HX-20, the second generation, is a mature, flexible, and available now string solution. While our 1 plus X modular inverter is particularly suitable for large and ultra-large projects requiring strong capex competitiveness, modular redundancy, and advanced grid support. The objective is to match the right architecture to the right project. It is no longer simply converting DC power to AC power. It now directly influences plant economics, commissioning, O&M, safety, and grid stability. With our string inverters and centralized inverters, Sungrow can support different utility scale project requirements with different architectures. So ultimately, the best solution is one that delivers the highest value over the full project lifetime. Okay, thank you, everyone. Thank you for listening.
Thank you so much, Mr. Thomas, for sharing the expert insights on the subject. Thank you so much for being with us. A quick reminder to all our audience here, and kindly post your questions in the Q&A box, and they will be taken up towards the end of the session by our experts. And it is again time for a rapid poll on the utility scale inverters. Kindly participate. Kindly share what is your biggest priority when selecting a utility scale inverter. Just few more seconds. Kindly share your polls. Requesting everybody to participate. Okay, thank you so much for participating, everyone. And moving to our next technical session, which talks about CNI BESS solutions. Now, may I request and welcome Mr. Fred Zhang, CNI BESS expert, Asia Pacific Sungrow, to kindly lead the session ahead. Mr. Fred, could we have you on the screen?
Hello, Gita. Yeah. Please wait a moment. Let me share my screen.
Sure.
Okay. Does everyone can see my screen?
Yes, we can.
Yeah. Okay. So good afternoon, everyone. I'm Fred from Sungrow CNIT. Yeah. And for my presentation, it's mainly focused on the CNIBS, and we definitely this model is for the pod stack. And from the first slide, you can see there's two versions. For the left side, it's for the 2 hours version for the pod stack 257 kilowatt hour. And on the right side is 4 hours version, 514 kilowatt hour. So both of them use AC coupling system design with 125 AC couple PCS. So that under this condition, for these two solutions, can provide for the 2 hours power supply and for the 4 hours power supply. So we have the flexible options for our end user. And there is a very quick brief video to show the power stack. So it is for the all-in-one system design, and for the cabinet from top to the bottom, the PCS, and also for the for this slide will be much clear to see the internal design from the top to the bottom is for the AC coupling PCS, and the PCS, it is for the liquid cooling machine. It is for the top cabinet, and between the PCS and the cooling machine, and on the bottom there is a battery module, and for the distribution box for the internal AC output and from DC to AC. And between these two parts there is a isolate design, so how the cabinet can support for the IP55 for the protection level, also suitable for the outdoor installation, and also for some the capability and for the overcurrent prevention. There's 3 levels from the modular design, and for the racks between module to module for the whole battery module, and also for the whole racks connected to the DC side at the PCS. There is totally 3 levels for the DC fuse protection. It is under the electrical circuit. And besides for the electrical safety design, and also for the internal fire extinguisher for some physical design, also we have the fire suppression and protection for the for standard configuration. It is for the flammable detector and heat detector, also for the smoke detector. All of these detector will be connected according to the DIDO signal, and when the detector receive any abnormal for the flame gas, like for the hydrogen and for the heat, or is more than 6 degrees, or is smoke volume is much higher, so it will send a signal to the LC, which definitely is a local controller in the BESS cabinet. Then it will send alarm to the customer. And besides for the detector, a built-in fire extinguisher module is for the aerosol. It also will, when the high temperature more than 90 degrees for the internal, then it will active to release aerosol to cooling down all the battery module and prevent there any fire to exist. And also there's some optional function for the sprinkler and for the explosion venting panels. Also for the whole cabinet, we can provide for these materials can be prevent the fire up to the 2 hours version. And all the safety design, we can get certificates, like for the explosion venting panel, we got the NFPA 68. Like for the thermal runway, for the modular design, for the rack design, we also got certificates for the 95408, and also for the internal circuit for the battery module. We follow for the IEC for this product. So you also got the IEC 62933 for the internal safety design. And besides for the safety design, for our product, the functionality and for the performance for the daily operation, for the RTE value, we definitely RTE is for the round trip efficiency. It means like, for example, for this cabinet, one single unit is 257 kilowatt hour. When we use a PV solar energy or use a grid to charge a battery, maybe we need to spend a little bit higher than the rated capacity of the battery. So for example, 255 kilowatt hour will cost 260 kilowatt hour to charge a battery until the 100% SOC. And this battery will discharge to supply the load. 257 kilowatt hour to supply to a load, and the load can receive the power, for example, is 240, and use 240 to divide it to 60. So we got the RT value. So this product can get the maximum RT value up to the 90%. And also for the PCS efficiency, the maximum efficiency under almost 25 degree is 98.5%. And for the system life, we definitely system life is on the basis of the battery cells. Even these cells can supply the cycles for the 8,000 cycles, but most of the time for this system, for the BESS, we not only discuss about for the BESS, we not only discuss about for the battery cells, we also consider for the BMS, consider the whole system integrated, like from modular design for the battery module, for the liquid cooling machine, for the PCS. So all the internal components for the can supply for the system life roughly can support at least 15 years. This is a one cycle per day. So it means like for the 365 cycles per year, or for the 400 cycles per year. And for the energy consumption, it is related to the internal liquid cooling machine. Compare with some traditional or compare with some previous cooling machine, it will cooling the internal temperature all the time. And for Sungrow, we modify the cooling machine operated logical. When it charge or discharge, it will cooling the battery module automatically. And when the battery standby, the cooling machine will stand by to save the internal battery energy and to increase the whole system efficiency. And also for Sungrow cooling machine, we can control the battery cells temperature difference less than 2.5 degree. We also have the pipe under each battery module. There's a cooling pipe, and we also to optimize the cooling solutions at the beginning, because the cooling liquid had a better performance. So the size of the cooling pipe will be a little bit smaller than the end of the cooling liquid pipe. So from the beginning until to the end, the cooling liquid have the same performance to keep the battery cells have the same temperature. And also for the next part is for the installation. So we definitely this pod stack all-in-one design. So it's a cabinet design as well as for the outdoor installation. So when we deliver this product to this on site, all the battery module or the PCS and the cooling machine is already pre-assembled in the cabinet. And when this product or customer or EPC receive this product, they only need to connect the power cable for the battery module, because we will during the shipment, it is disconnected at a positive and a negative connect port. And besides for the power cable at the DC side, the last step is only for the AC cable at the bottom to the main distribution box, or if you need to parallel multiple units, so the AC cable will be connected to bus bar as the next step to the EPC or to the installer. This is for the physical installation. Besides this cable connection, the next part, the last part is only for the software for the EMS. So it will, when this product delivery on site for the installation, it will save a lot of time. And for the layout, this is just a sample. It can support side by side, so it is seamless. Can save a lot of space for on-site. Also can support for the face-to-face or for the back-to-back. Just for the face-to-face, we usually recommended around 2.5 or for the 3 meters. to prevent to suggest customer to reserve enough space to open the door or for the future maintenance. And for the back-to-back, at least we will recommend 600 millimeter just for the heating dissipation. And if some of the cabinets configured with the explosion venting panel, so when installed back-to-back this method, the distance between two units will extend from 600 millimeter to the 1 meter. And for the parallel, when the purely on-grid mode, it means like the grid will never black out. It can support for the 25 units. And some of the projects need the on-grid to switch to the off-grid or purely off-grid. This product can be parallel up to the 20 units. And both of this connection we can support for the seamless function. And next slide, I like to make some introduction for the CNI application or for the scenarios. Usually, I think for the Nepal, for the Southeast Asia market or for the South Asia market, most of customers select to the CNI BESS. It's for the self-consumption and for the emergency backup, as well as for the microgrid or for the energy upcharge. And the Sungrow we definitely for the self-consumption. It means like the PV to supply the load as the first priority, and the extra solar energy will charge to a battery until the PV is not enough. Then the BESS will discharge automatically to supply the load. And besides for the self-consumption, another application is for the energy upcharge. Sungrow definitely is for the time of use. We have the specific time to charge or to discharge, so customer can set the value or can set a temporary according to the EMS. And for the BESS will follow the EMS order to operate it. And on the basis of the self-consumption or for the energy upcharge or for the time of use, at the same time, the EMS also can run for the emergency backup for the transfer from the on-grid to the off-grid. Also can support for the microgrid or for the zero export. And for the service, just to make a brief introduction, from the Sungrow, we usually to provide our CNI service for the one-stop facilitation. Usually at the beginning or at maybe the first project or to the maybe 3 or to 5 projects, our service engineer will support to the on-site to help our EPC, help our customer to commission, to install the CNI BESS. And also we have some call center, have the service engineer can provide the technical support from the remote, and also can provide the technical support for the local as well. And last part, just show some the project reference. This one is for the in 2024. It is installed in the South Africa, and also for the seamless transfer. It has this is a little bit different because like on the right side is for the pod stack, have the 2 units, but it's for the previous version. Its capacity is 225 kilowatt hour per unit. And on the left side, it is for the ATS cabinet, which is internal components is for the static transfer switch, which can support for the seamless transfer. And all this project is for the self-consumption as well as for the emergency backup. And this one is installed for the last year. It is installed in the Indonesia, in the Kalimantan, Iceland, and it is for the purely off-grid application. So customer select or install the PV panels with the Sungrow PV inverter and combine with the CNI BESS for the daily self-consumption. And when the solar energy is not enough or for the BESS has a low SOC, then EMS will send the order to the diesel generator, and the generator will be as a backup of the BESS. Yeah. That's all. Also, it is for the details for the Indonesia. Have the 4 units. Yeah, that's all. It's my presentation for the CNI BESS.
Thank you so much, Mr. Fred, for that very informative and valuable insights on the Sungrow. And as we transition ahead to our next presentation, please help us understand the challenges for utility scale solar in Nepal by participating in our next poll. Please do let us know what is the biggest challenge for utility scale solar in Nepal. Looking forward to your participation. I do see some very interesting results here. Again, requesting everybody to please participate in the poll. Just a few more moments before we end the poll. Thank you so much, audience. Ending the poll now. Thank you very much for your participation. And now let us move to our final technical webinar workshop on utility BESS solution. And may I invite our expert, Mr. Carl Cow, utility BESS expert, Asia Pacific, Sungrow, to kindly take the session ahead. Could we have you on the screen, Mr. Carl?
Yeah, okay. Thank you, Gita.
Thank you.
Okay, so can everyone see my screen?
Yes, we can.
Yeah, okay. So hello everyone. Today I want to introduce our Power Titan series product. From the screen, we can see it's our Power Titan 3. Our Power Titan 3 adopts 684 ampere hour stacked cells. Within the same 20 feet battery container, the capacity increased to 7.1 megawatt hour. Power Titan 3 continues the full liquid cooling and integrated design like Power Titan 2. And the Power Titan 3 adopts the string version PCS, which is built in the battery container to realize rack level management, which can reduce the barrel effect and inter-rack circulation. And after that, we can increase our usable capacity and revenue. And in terms of economics, safety, and reliability, Power Titan 3 has been also comprehensively upgraded. And now, in this slide, we can see it's our last generation Power Titan 2 liquid cooling energy storage system of 10.5 C block. One 20 feet battery container can also provide 2.5 megawatts, 5 megawatt hour capacity. And Power Titan 3 2 also use the string version PCS, which built in the battery container and to achieve one PCS for one rack design. And the system RTE for Power Titan 2 can achieve 89.5%, and the system noise less than 75 dBA. And from this slide, we can see the comparison between Power Titan 3 and Power Titan 2. First, let's look at the battery cell technology. For Power 3, we adopt a 684 ampere-hour large capacity cell, and for Power 2, we use 314 ampere-hour cell. And thanks to the large cell capacity and the higher integration level, the energy capacity of Power 3 can now reach 7.144 megawatt-hour, while Power 2 can provide around 5 megawatt-hour. And we also increased the PCS size from 210 kilowatt to 450 kilowatt-hour. And after this slide, I will introduce the highlight and the function of our Power 3 product. So this page is about the system RTE. For our Power 3, we have three mainly technical progress. The first is we redefine the battery cell from 314 ampere hour to 684 ampere hour. With stacking technology and the peak efficiency can achieve 96.5%. And the second point is we use the full liquid cooled silicon carbide PCS with the maximum efficiency more than 99.3%. And the third point is we have plant-level thermal management, which can reduce the auxiliary power by 10%. So thanks to this technical progress, the system RTE can achieve 92% at the LV side. So that means we can have more useful capacity and have more revenue. And in terms of thermal management, our purpose is to reduce auxiliary power consumption. Power 3 builds a thermoelectric and fluid coupled predictive model, which can optimize both system design and control strategy. At the system level, we adopt a plant-wide airflow coordination design. With the top airflow layout, the thermal interference between the MV station and the ESS is effectively reduced. And compared with traditional design, air inlet temperature rise is reduced from 8 degrees C to 1.5 degrees C, which can significantly reduce the cooling demand. And in addition, with the bionic thermal balance technology, the system applies a one-site, one-strategy approach to dynamically optimize the performance under different conditions. So as a result, the auxiliary power consumption can be reduced by over 10%. And due to the stacking cell technology, the energy density per container can achieve 467 kilowatt-hour per square meters. Also, together with the 15 centimeters back-to-back arrangement design, for each 1 gigawatt-hour power plant, the footprint can be reduced by 22%. So as a result, the construction workload is significantly reduced, and the initial investment can be lower in a substantial way. And also, if for some space which have the land requirement, so which can also reduce the land requirement and the land cost. And however, high performance alone is not enough. In real projects, delivery speed directly determines how fast you can start generating revenue. So Power 3 continues Sungrow's integrated AC/DC design advantage. This is the advantage that means we put the PCS inside the battery container, and the DC cable is also Sungrow's scope. And Power 3 have the the PCS, pack, BMS, and EMS are Sungrow self-developed, so the data exchange and the control logic are consistent. So the DC cabling, PCS installation, communication test, file separation system test, even charging and discharging test can all be done before the product leaving the factory. And even after the equipment is installed on site, there is still a large amount of configuration and inspection work to be done before grid connection. So in a traditional gigawatt-hour plant, and engineers need to configure and commissioning hundreds of PCIs by one. And this process usually takes at least 17 days. With our innovations such as self-configuration and self-check function, the entire plant configuration and inspection can now be completed within 1 hour. This means the plant can be connected to the grid much easier and start generating revenue much sooner. And now let's move to the safety performance of Power 3. At the battery level, Power 3 adopts a dual safety design with one clear objective to prevent the thermal runaway propagation as much as possible. So through thermal electric separation, directional venting design, and coordinated safety technologies, the system enables easier fault detection, faster warning, and stronger isolation. Unlike traditional layouts where the thermal paths and the electrical paths are arranged on the same side, Partner 3 separated the electrode side and the venting side, making heat release and electrical pathways independent, and reducing the risk of fault propagation. At the same time, the system performs upgraded alarm and proactive isolation, so providing at least 10 minutes of early warning with one accuracy of over 99%. It also supports lithium plating diagnosis with an accuracy of over 95%. So in other words, we focus not only on controlling incidents after they occur, but more importantly on identifying and preventing them in advance. And another major safety risk in high-power DC system is arc fault. With larger cells, the DC current is much higher, and this makes arc detection much more difficult. So our Arc Defender technology features more sensitive current sensors and smarter AI algorithm. So even when the DC current reaches 500 ampere, the system can still achieve 100% detection accuracy with zero missed detection. At the same time, the arc extinguish speed is more rapid, and the risk can be cut off within just 0.1 seconds, which can significantly improve the system reliability. And the Power 3 also integrated with linkage fire protection design, ensuring no ignition or separate under extreme conditions. Our system compliant with NFPA 855, 86, and 668 and 69. And first, the system adopts a partitioned design that separates the battery cabinet from the electrical cabinet. It is also equipped with multiple integrated safety systems, including detection, ventilation, deflagration, and suppression. And in our system, we build in the smoke detector, heat detector, and the flammable gas detector. We also have the aerosol water sprinkler and the explosion wind panel. And in addition, Power Titan series have been validated through extreme station level burning tests, demonstrating completed preventing. So for our Power 3, it's also have the 15 centimeters back-to-back arrangement, so which can reduce the land cost and more convenience to O&M. And to validate the safety performance of the system in real applications, we conducted more than 770 high-standard tests covering the cell, pack, rack, PCS, and the full system, such as penetration nail penetration test for the seal and some high temperature test, EMS test, liquid cooling system test. During this safety test, we can ensure the reliable operation of the system. And finally, I would like to talk about the grid adaptability, which is becoming more and more important as renewable penetration continues to rise worldwide. Therefore, energy storage system should not only be able to absorb green energy, but also be able to actively support the grid. As early as 2021, Sungrow proposed the concept of steam cell grid technology through AI-based grid condition sensing, PV and storage coordination, grid forming control. We are able to inject system level stability into renewable power plant and ensure grid stability under all operation scenarios. From the cover the generation side, grid side, demand side, or even micro grid. And up to today, the Power Titan series have been deployed more than 100 gigawatt hour worldwide. So this deploy shows is the best proof that our product is not only advanced, but also mature, reliable, and ready for long-term operation. So this is the content of my presentation. Thank you very much.
Thank you so much. Thank you, Mr. Carl, for a very excellent presentation and for sharing such valuable perspective on utility scale energy storage. And I'm sure the technical presentations and insights on Sungrow solutions by our experts are a great takeaway for today's audience. And you must have posted your questions in the Q&A box for the experts to answer. If not, then please do it right now. Meanwhile, let us have a quick poll to know which Sungrow solution is the most relevant for your current projects. To let us know which Sungrow solution is most relevant for your current projects. Requesting again everybody to kindly participate in the poll. Just a few moments more. Do participate in the poll, everybody. Thank you so much for sharing your perspectives. Thank you for participation. Ending the poll now. And now let us get to the much anticipated part. The forum is open for your questions and our experts are ready to answer as many of your questions as time allows. I would request all of our Sungrow experts to kindly come on the screen. And I would request Mr. Himanshu to kindly address these questions to our experts today. So audience, if you have not posted it yet, now is the time for you. So kindly post your questions. Mr. Himanshu, I'll just request you to address the questions to our panelist here. Requesting all the speakers to kindly come on the screen. Mr. Himanshu. Requesting our panel speakers, all speakers to kindly come on the screen so that we could open the forum for the Q&A. Yes, Mr. Himanshu, would you like to take the first question and address it to our technical experts?
Yeah, sure. You see, the question that the audience have put up to us is the first question that has come to us is that how do your latest inverters perform during low voltage ride through, high voltage ride through, and frequent grid disturbances? And I believe Mr. Thomas and Mr. Monu will be able to address this question for us over here.
Sure. Mr. Thomas, Mr. Monu, kindly
Yeah,
take this
hello
question ahead.
everyone.
Yeah.
My name is Manu Devadia and I am from Sungrow technical team. So let's discuss about LVRT and HVRT. So our inverter 320 and 350 HX have this feature LVRT and HVRT voltage right through. In the event of grid fluctuation, right? In the HVRT condition, we have to set a voltage level like 1.1. We have to set the LVRT set point. On the basis of that set point, inverter priority is reactive power absorption. In the same uh, vice versa in LVRT condition. In LVRT condition, inverter have to respond inverter have to feed reactive power in the grid, and we can set that points set points like 0.95 pu, zero point 0.9 pu, 0.85 pu according to local conditions as per local grid code requirement. Thank you.
Can we move to the next question, Mr. Himanshu?
Yes, please. Another one that has come up to our panel is that what are the string inverter outputs at high temperatures, 45 degree and 50 degrees Celsius? Mr.
Hello.
Thomas, Monu?
Yes. For SG510 at 40 degrees Celsius, it can deliver 465 kilowatts. And at 50 degrees Celsius, it can deliver 420 kilowatts. And as per our SG350, the second generation, at 40 degrees Celsius, it can deliver 320 kilowatts. And at 50 degrees Celsius, it can deliver 295 kilowatts. Okay, thank you.
The audience wants to understand how does the multi-MPPT architecture improve energy yield on Nepal's uneven terrain and complex land profiles?
Okay, let's discuss about multi MPPT technology, right? So our inverter have SG320 and SG50 HX-20 have 6 MPPT, and each MPPT have 5 inputs. Okay, this configuration is very helpful in uneven terrain, right? Because due to uneven terrain, it is very important to select a string or to manage similar DC in our each input DC input. So multi in that scenario, multi MPPT configuration algorithm will helps to optimize our DC power on block level. Okay, it will help us to minimize mismatch losses due to different orientation, due to uneven terrain, due to different cable lengths. Okay, so this multi MPPT configuration will help us to increase our DC input, and it will help us to optimize our generation.
Very well. Another one that we've got over here is what reactive power capabilities are available at night And could this be valuable? And how could this be valuable for Nepal's grid?
Our latest inverter have 60% of rated, right? Like our SG320 HX-20 have rated output is 320 kilowatt at 40 degree. So 60% of that 320 kilowatt we can supply it as reactive power. It will help to achieve the local requirement of reactive power at plant level, at POI level. We can achieve that level, that requirement.
Thanks, Mr. Monu, for your valuable input. Another one of the questions that we have got from the audience is with respect to the Power Titan 3.0. That is, what is the round trip efficiency for Power Titan 3.0?
So you mean the RTE for the Power Titan 3, right?
Yes.
Okay. For Power Titan 3, the RTE can achieve 92% at the LV side. So that means at the 690 volt side, output of our PCS.
Another one of the queries is with respect to, is it DC coupled? Can it be DC coupled also? Power
Yes,
Titan 3.0.
yes, our Power Titan 3 also support the DC coupled solution.
Okay, thank you. Another one of the questions that we have got from our audience is with respect to the CNFS. Mr. Fred,
Yes.
if you can tell our audience, the question that they have put up to us is, what is the degradation of CNFS?
Decoration, yeah. For the decoration for CNB is roughly as a reference until the 10 years, the SOH is almost 80%, and 20 years is 70%, and 25 roughly is around 65 or 64. But it depends on how many cycles and the depth of discharge. This is for the reference, like 10 years, 80%, and 20 years, 70% for the decoration.
This one is with respect to the inverters itself. How can
it is mainly for the battery cells and for the battery cells.
Yes, the question is, what would Sungrow recommend in between choosing of the SG320, SG510, and 1 plus X architecture modular inverters based upon plant size and site conditions? Mr. Thomas, Mr. Monu?
Yeah, sir. Can you repeat, sir?
The question's been put up to us. What would be Sungrow recommendation while choosing the inverters in between SG320, SG510, and modular 1 plus X architecture based upon plant size and plant size?
Okay. Thank you, Himanshu. I think for smaller and terrain complex utility projects like on a hill or something, SG320HX-20, the second generation is very practical. Because for 1 plus X, you need to build a foundation for the inverter. It's not a complex one, but there's still a concrete foundation needed to put the inverter. So I think it needs a relatively flat land. But for our string inverters, you just have to hang it on the panel poles or something, just to put it there. And also for transport and logistics, 1+X needs trucks or cranes. Also means a good road to deliver the equipments to the site. So I think for these terrain complex utility projects, we can use string inverters. And for larger project, I still recommend our central inverter because the capex per watt is lower, I think. Thank you.
Another one of the question is a bit specific that has come to us. The client is having an existing plant setup of 500 kilowatt grid tied inverter using 5 numbers of 110 CX itself. He wants to have the information if he wants to integrate a battery backup system. What would be Sungrow's recommendation for the same? Mr. Fred, Mr. Monu?
Yeah.
Sorry? For which question?
One of our audience members is already having a 500 kilowatt solar system installed at his client's premises using 5 numbers of 100 kilowatt Sungrow inverters. He intends to integrate battery energy storage system into the current solar plant. He wants to know Sungrow's recommendation for BESS.
It depends on like they already. So you means like already have 500 kilowatt for the PV inverter, and they need to know the recommendation for the BESS capacity. Basically, I recommended. It also depends on its daily load consumption. And from my recommendation, it's roughly is around 500 kilowatt and PCS output and 1 megawatt hour for the battery capacity. The PCS have the same power with the PV inverter, and for the battery capacity, it depends on like a customer need the 2 hours battery or for the 4 hours battery.
Yeah, there's a lot of questions and we are running out of time. One question we can pick up from here, the last one, just got it from one of our esteemed members. I'll like to address this question myself. It's with respect to the technical support and replacement units that are available locally in the Nepal. So we can tell you that we are having round-the-clock technical support available for the Nepal market. And as far as the spare inverters are concerned, our local channel partners are already having local spare inverters in their warehouses to address any of the warranty concerns coming up real time. For all the rest questions, I will ask you to please send them on our personal email addresses. I'll post my contact details, my phone number, my email address. You can contact us directly and we will get back to you personally, specifically as per your requirements. I'll be putting up my email address and contact number in the chat.
Thank you so much, Mr. Himanshu. We will be sharing a thank you email to all our attendees, and I'll be glad to share the contact over the email to all our attendees of today. For rest of the questions, as Mr. Himanshu said, they will be taken offline and be glad to address it. And ladies and gentlemen, as we come to the end of today's webinar, I would extend my heartfelt thanks to all our expert speakers, Mr. Himanshu, Mr. Karl, Mr. Monu, Mr. Fred, and Mr. Thomas, for sharing their expertise and valuable insights here today. A special thank you to our webinar partner, Sungrow, for bringing together this informative knowledge sharing session. And most importantly, thank you all our attendees and audience for your enthusiastic participation and thoughtful questions. We hope today's discussions have given you valuable insights into advanced inverter technologies, battery energy storage systems, and the innovations that are shaping